Alright, so I decided to learn how to do requests, get posts, etc. in Rust. And there seems to be a crate dedicated to that called Reqwest. In this video, I'd like to go over how to use it, like the basics of using it, but also a lot of the pitfalls I ran into trying to use it. Let's get it. Alright, first and foremost, let's go over what Reqwest is, right? Based on the crates.io page, it is an ergonomic batteries included HTTP client for Rust. Right there. Basically what that means is you can do HTTP requests with this crate. Some of the pitfalls I ran into dealt with, all really revolved around three separate things. One, previous experience with similar libraries in other languages. Two, outdated documentation. And three, bad habits when it comes to documentation. Alright, so going over pitfall number one, I expected Reqwest, the Rust crate, to work similar to the request library I'm used to in Python. So in Python, we have a package called Reqwest. It's spelled with a U instead of a W. And it is a HTTP library for Python. So it does all the same stuff. It accomplishes the same goal. And because this works synchronously, I expected the other one to work synchronously. However, that is the major difference. They accomplish the same goal, end goal, making HTTP requests, but the Python library is synchronous by default, whereas the Rust library, or crate, is asynchronous by default. And that threw me for a loop, because I didn't really expect that. Alright, move on to the next one. Alright, 2 is the documentation thing I was talking about. So I mentioned earlier in a previous video about the Rust cookbook, and I've been going through it, I've been looking at it, and they have a complete section dedicated to clients and making requests. And the request section is seemingly just going over how to use requests. So one thing to note here is that this documentation or this example doesn't work with the current version of requests, which is confusing because you can see right here the link to the documentation points to the current version of requests. This is a known issue. None of the examples should work. Pro tip, you can open the GitHub page for the cookbook and then look at what version of request they're actually using for these examples. Let's go find that real quick. GitHub cookbook. And once you're on their page, you can just look at their cargo.toml file. And it shows, where is it, request. They're using version 0.9, which is not 10.4. So I haven't tried this out, but I presume that all these examples work with request 0.9. In any case, this is a known issue. Shout out to Belval. Shout out to Belval for reporting it both on the cookbook website or GitHub and the Reqwest GitHub. So thank you for being a good citizen. So that was the outdated documentation. Like I was reading this, and based on this, it seems as though Reqwest is synchronous by default. And at one point in time, it probably was. Probably before the 10.0 version. But now it is not, so this doesn't work. Alright, and then lastly, what I wanted to go over was some of the bad habits I have when it comes to reading documentation, and I don't want anybody else to fall into these pitfalls, which is, I come to the crates page, I see the request library, and I see a link to documentation. And instead of reading what's on this page, I go straight to the documentation, I start reading from here. So yes, the documentation is the end-all be-all, has all the information for you. However, I've come to realize that the crates.io page is used to highlight things that you need to know immediately before you can actually do stuff. Now, if I were to scroll down, I would have saw two things. One, the asynchronous examples use Tokyo, which I had to look that up, but it's an asynchronous runtime for Rust. And here's an example of the dependencies, and here's an example of how to use it. But two, more importantly, I would have saw blocking client. This option has to be enabled, and they give an example, as in this is a feature flag. And if you want to use it, everything is behind the blocking module, seemingly, like request blocking. That would have saved me a lot of time. Now, though this information is in the documentation and you can find it, it is just harder to grasp and see, because I go here and I see blocking. I'm like, okay, blocking. And I see that this is an optional, but it doesn't like jump out at me. And there's no example of like turning the flag on. That's in the Crazcalm page. Also something to note is that when you're looking at the documentation, the examples give us the function body. And in the function body, you can see things that may look strange, like the .await, which gives you a hint that this is asynchronous code. But you typically don't see the function signature in examples, but that would have made it more apparent as to how to go about writing it. And they did have an example of that in the request here, where they had the full async signature, main, they even have Tokyo there. But here you can see it's just a body. One of the takeaways that I took away from this is there's an implicit expectation that you already know how to write asynchronous code. Speaking of which, if you want to do the asynchronous calls for requests, then you need to learn how to do asynchronous stuff, right? So going back here, they mentioned Tokyo, and if you go to the Tokyo documentation page, which I think I already had open, here we go. They have like an overview, what is Tokyo, yada yada yada. Tokyo has links and documentation for how to use Tokyo, but from the brief look I took at it, it doesn't tell you how to do asynchronous stuff. Like it doesn't teach you how to write asynchronous code. There is a GitHub book for it. You can search for like asynchronous Rust book, and one does pop up. I've seen this before and I haven't read it, mainly because on the side I can see that the book is not finished. There are a lot of to-dos, so I just wrote the book off as not being complete. However, if you just need to learn enough to be dangerous, then reading the primer is pretty much all you need. And then like the general concept of asynchronous programming, you can learn from any language documentation. Right now everybody's seemingly just converging on the same syntax. The general basics of it is all the same. On a note for this book, in this example, or at least this video tutorial, I did steal their simple HTTP server because I needed an echo server just so I can see things go back and forth. So the echo server I'm using is just based off this documentation here. All right, that being said, let's get to making requests and figuring out how this is done. So minimize that, open my terminal and open my editor. So in my editor, I already have the echo server running. Have some warnings, meh. An example there, but the echo server is running there, and then here I labeled it Rust Cookbook because that's where I started. But this is just synchronous examples, blocking examples. So before we look at the examples, let's look at the cargo.toml file. Here we go. So in order to enable the blocking feature, you need to use the feature flag and put blocking in there. JSON's there because I used some JSON examples as well. And this is for version 10 and up. All right, so let's go with the first one. So first, let's do a basic GET request, right? And for a GET request, we can look at it here. We can note two things. One, request is behind blocking, and blocking has its own GET. So one thing you may have noticed if you looked at the documentation on the page for request, here we go, is that they have a shortcut, right? Request GET, but this shortcut is for the asynchronous version of request, not the synchronous version, which is the blocking version. As such, if you want to use the blocking version, you have to enter the blocking API. So let me minimize that. And here we go. And that's just going to be a common theme. Everything's going to be behind the blocking API. So request, blocking, get, and it works the same way. So if you look here, you can see I'm returning a result, right? And the result has a response. And this response is also behind the blocking API. So seemingly everything that's associated with the blocking API is behind the blocking API. With the exception of errors, I think, because for errors, I'm just using the generic request error. Okay. Anyway, request, blocking, get. Got it. And return something. And then I have that right here. Oh, down here I have, this was taken from the Rust cookbook for the most part, just the general layout, where they write things to, they write the body to a string, and then they print out the status headers, yada, yada, yada. So let's run that, right? And over here we see that it is a GET request, which is what we wanted. And URI, there was nothing there. We have the version of the HTTP protocol. We have the headers, the host, which I'm running the Echo server on localhost port 3000. And we have an empty body. Okay. That's really what we should expect. It's just getting stuff. So let's do a post request. And then here we go. Here's the post request code. So here it's request, blocking, client, new. So one thing I noticed when looking at the request documentation, and we can pull it up real quick, is that they suggest using a client for everything. The request client is asynchronous, at least that one is. If you put it behind blocking, it's blocking. But for applications wishing to only make a few HTTP requests, the blocking API might be more convenient. Hold on, where is it? Here we go. If you plan to perform multiple requests, it is best to create a client and reuse it, taking advantage of keep alive connection pooling. Okay, so they note there that we should be using a client if we're trying to do anything complicated or multiple requests, right? And the way to use the client for the blocking version is blocking client new. So everything's the same for the most part, but there's blocking. And then post, you have the body, you have the send. So let's look at client real quick. And let's go to the blocking documentation, because that's actually really important. So go to the blocking documentation. We see that we're in blocking. Note that there. And here we have client. So here, blocking, client new. This exists, get, send, yada, yada, yada. What we really want to know is this chain thing is acting on whatever get is returning. So what is get returning? And get is returning a request builder. And both for the asynchronous and synchronous versions, request builder is where all the hard work is being done. Like when you want to interact with things, this is where you do it. So we have like functions for adding headers. We have functions for adding multiple headers at once. Basic off. Want to put things into the body. Timeouts, query, form, JSON. Most of everything you want to do is going to happen on the request builder, which is going to be returned from client get, client post, yada, yada, yada. And that's going to be a common theme as well. So here we have request, blocking, client, new. And then we have request, client, post, URL, which is just a string. We already know this. And we're going to put something into the body, just a stream of bytes. And then we're going to send it, and we're going to be like, okay, what did we get back? So let's do that real quick. Oh, one thing I forgot to note, the Echo server is just returning hello world. All cases, it's not returning anything else. So I guess technically it's not an Echo server, it's just a server that logs stuff. My bad. Okay. So over here we see the request. It's a request. We see that it is a post, which is what we want. we see that it has a content length, which means the body of stuff that we sent over is actually there because it's a length of 18 bytes seemingly. And the body is streaming. It got broken up to 2 pages, but it looks like if you wanted to get access to what was sent, you have to go into the body, and it's a streaming API seemingly. I'm not exactly sure. I didn't dig that deep into it. But everything is in body. That we know for certain. Cool. All right, so let's move on how to do a form. Oh, and to note, it should be noted that a lot of this documentation is in, a lot of the code for this is just coming straight from the documentation. I just wrote it in blocking or asynchronous. So the form example, we have a tuple, we have our items, I think it's key and value, yada, yada, yada. We do post, we do form, which is going to be called on the request builder, and then we pass in the params, which gets converted to what they need to be converted to, and then we send. So let's run that. And here we go. So over here, you notice that it's still a post because we want it to be a post. But what changed is the content type. The content type now denotes that it is a form, which is correct because we did a dot form. That's what we wanted to send. And it knows the length, which is 16. So cool. Good to know that worked. All right, moving on to the next one. Sending JSON. For sending JSON, we have in the example, which is also from the documentation, we just create a map, right? A hash map with our key and values, and then we do the same thing, request blocking client new, post, and then we do .json and we pass in the map. That's it. So everything here is seemingly pretty straightforward. Do that. And over here at the server, we see it. It's a post. And you note that the application JSON is the content type. So that changed appropriately. And we have a new content length. And everything's in the body, streaming, just like before. Cool. And then lastly, what I wanted to go over, at least for the blocking, is adding headers. So if you want to add headers to a post request, all you really need to do is look at the documentation for request builder and figure out if you want to add one header or multiple headers. For a single header, you need to do this. Dot header is the call. One thing to note is that the header map or dictionary, which they implemented themselves, it's not the hash map dictionary implementation. They seemingly have their own. Anyway, it only accepts headers that are, I guess, registered, and to look at those, they're in the documentation as well. Let me find it real quick. Here we go, header. If you go to request header, you can see the long list of constants, and these constants are seemingly the available keys that are allowed for the header map, and there are a ton of them here. Anyway, once you know that, you can just import header and then pick which header you want. I did accept and I changed the value to value just as an example. So over here, we now see headers, accept, value. It also should be noted that everything else in this example is the same as the JSON request. So this is also a JSON request that has a new header that we added. All right, so for request synchronous, or the blocking portion, the big takeaways are everything you need is behind the blocking API. If you want to look at the blocking API, you can just start by, let's start from the beginning. You can come here, you can click on blocking, and then in blocking, when you click on these structs, it'll bring you within the blocking API. So the documentation for the structs that you can use while using the blocking API for the most part. Cool. All right, so moving on to the asynchronous portion. Let me open that up. Open, there we go, this window. Overall, I just did the same exact layout just for asynchronous stuff. One thing to note is some of the glaring differences. One is the use of the async keyword. Two is this Tokyo main thing. So for the async keyword, if you want to understand that and how that's used or why it's used, the asynchronous book, where is it? I'll put links to all this in the bottom, but the asynchronous book goes over it and in the primer. So reading the primer will tell you why we use async and like the purpose of it. In terms of the Tokyo main stuff, I'm not exactly sure. I know that you need a main, and for some reason this attribute works to make it a main. I don't know what to tell you. I haven't really dug deep into Tokyo yet. But those two things aside, let's look at the examples. So everything the same, the setup is the same. We're going to the same URL, yada yada yada. And technically speaking, it's not an echo server. My bad. But let's look at a GET request. And GET request, we notice that the response is now just response. There is no blocking, and error is the same as before, just the request error. One thing to note is the awaits. Now that we're using the asynchronous version, we have to start using asynchronous syntax, including the awaits. So we await seemingly just waits for the task to finish or the request to be completed, and then we return that. Cool. And let's run that. All right, so we have the GET request. Everything is the same as before. All of these should be the same as before. All we're going to see really is just different syntax and how it was written, but even that is more or less the same. So yeah, GET body is empty, accepts anything, has the version. Cool. Moving on to the next one. Post request. I run the post now. You can go look at it. So for a post request, we use the client, is not behind blocking, client new, post, use the body. The API is more or less the same, at least from what I can tell. When I was writing this, I actually didn't look at the blocking documentation for client. I just looked at the documentation for the asynchronous one and did the same stuff, and it worked. With the exception of await. I mean, you gotta remove the awaits. So over here, we see that it's a post, version host, body is streaming because body exists. Cool. Everything more or less the same. Form. Same layout, tuple, key value, client, post, dot form, passing the params, await. And over here we can see that the application type is form URL encoded. And the length is 16. So that's the same. Post JSON request, same exact example. Map, new client, post.json, pass and map. Then you await. And over here we have our content type, application JSON, yada yada yada, body streaming. Cool. Last but not least, the add headers request, which I can also run that. Same as before, did the hash map for the JSON stuff, and then I changed the header, got the appropriate header, and then changed the value, and we can see that here. Header for accept is value. And that's more or less it. So outside of the hurdles to getting started, once you realize it is asynchronous and that you have to learn at least a little asynchronous stuff to use it asynchronously, everything else is pretty straightforward, like the API and documentation and stuff like that. Alright, so with that, we've reached the end of the video. If you like, hit like, subscribe, yada yada yada. Outside of that, see you next time.
Peace.